Welcome to the DIY Honda Garage channel. This presentation addresses diagnostic trouble codes DTC P0455 and P0456 related to the evaporative emission control EVAP system in the Honda Accord models produced between 2017 and 2023. DTC P0455 indicates a very large leak within the EVAP system, while DTC P0456 signifies a very small leak. The EVAP system captures gasoline vapors from the fuel tank and routes them to the engine for combustion, thereby reducing harmful emissions. Components such as the EVAP canister, purge valve, and vent shut valve play critical roles in this process. Precise diagnosis is crucial, as any leaks can lead to increased emissions and affect performance. Understanding how to identify and fix these issues will enhance the reliability and sustainability of your Honda Accord. The EVAP system's primary function is to minimize hydrocarbon emissions by capturing and recycling fuel vapors. The major components involved include the EVAP canister, which stores vapor, and the purge valve, which allows the engine to draw in those vapors for combustion. An additional critical element is the vent shut valve, which prevents outside air from entering the system during operation. All these components are strategically located around the fuel tank and engine compartment, with the canister typically situated within the rear of the vehicle near the fuel tank. Diagnosing issues related to these components is integral for ensuring compliance with emissions regulations and maintaining optimal vehicle performance. There are several potential causes for the DTC P0455 and P0456 codes. One common issue involves faulty hoses or connections that can develop cracks or loosen over time, leading to leaks in the EVAP system. Additionally, damaged components such as the EVAP canister or various valves can contribute to the problem. Another significant factor may include improper fuel fill procedures. For instance, overfilling the fuel tank can lead to liquid fuel entering the vapor lines, creating potential loss of pressure or blockage. Thoroughly inspecting each of these areas is necessary to determine the root cause of the detected leaks. Symptoms indicative of DTC P0455 and P0456 may vary, but one of the most common signs is the illumination of the check engine light on the dashboard. Drivers may also notice a fuel odor, especially after refueling, which can signal a leak in the EVAP system. Additionally, there may be performance issues such as reduced fuel efficiency or unstable engine performance, as the engine may not be able to manage fuel vapors effectively. Being attentive to these symptoms and addressing them promptly can prevent more severe issues later on. The first step in troubleshooting DTC P0455 and P0456 involves verifying the problem. Start by turning the vehicle to the on mode, which energizes the electrical systems without starting the engine. Next, utilize the Honda Diagnostic system, known as HDS, to clear the existing DTC. Clearing the DTC enables the system to reassess the EVAP system's performance without prior fault codes interfering. Following the DTC clearance, proceed to select the EVAP test function in the HDS. This test will help determine whether the system is currently functioning correctly. If the test results indicate a problem, continue with further troubleshooting. If not, check for intermittent failures, such as poor connections or loose terminals. In this step, the next phase of troubleshooting begins by turning the vehicle to the off or lock mode. Once in this position, remove the EVAP canister vent hose from its connection. A thorough inspection of the vent hose is then conducted to ascertain whether there is any blockage or restriction present. Blockages can prevent proper airflow within the EVAP system, leading to excessive pressure and ultimately triggering the DTC codes. If a blockage is identified, it may be necessary to clear it. and depending on the severity, replacing the vent hose could be required. If there are no visible issues, reconnect the hose and advance to the subsequent step. The third step focuses on inspecting the fuel tank vapor recirculation tube. This involves checking for secure and undamaged connections, as well as looking for any physical damage to the tube itself. The fuel tank vapor recirculation tube is essential for returning captured vapors from the fuel tank back into the engine intake. If this tube is compromised, it can lead to significant leaks that trigger the DTC codes. If it is determined that the tube is in good condition, troubleshooting continues. However, if any damage or poor connections are detected, it may necessitate replacing the tube or the entire fuel tank assembly. In this step, attention is turned to the EVAP canister purge valve, located in the engine compartment. To begin, disconnect the vacuum hose from this valve and prepare to attach a T-fitting, along with a vacuum gauge, using the specified pressure range. Slowly apply a vacuum of approximately 2 kilopascals or 0.6 inches of mercury to the hose. It is essential to observe whether the vacuum holds steady for at least 1 minute. If vacuum can be maintained without any leaks, this indicates that the valve is functioning correctly, allowing vapors to pass to the engine efficiently. On the contrary, if the vacuum does not hold, it suggests a leak present at the EVAP canister purge valve, necessitating its replacement. In troubleshooting step 5, disconnect the fuel vent tube from the EVAP canister, ensuring to plug the opening securely. Next, connect the previously assembled T-fitting, vacuum gauge, and vacuum pump to the purge line. After setting up, turn the vehicle to the on mode and select the EVAP test for single solenoid through the HDS interface. The next step is critical. Apply vacuum to the hose until the fuel tank pressure, FTP, sensor reads approximately 1.90 volts. During this process, it's important to monitor the FTP sensor readings closely. After applying vacuum, if the sensor voltage increases more than 0.2 volts, the system is functioning as designed, and you can proceed to the next step. However, if the increase is less than 0.2 volts, further troubleshooting is warranted. At this stage, the focus shifts to the EVAP canister vent shut valve operation. First, navigate through the HDS to select the EVAP test function to turn the vent shut valve off. You must disconnect the vent hose from the valve port and then apply vacuum to that hose while still monitoring the FTP sensor. The objective is to ensure that the FTP reading again indicates 1.90 volts. Achieving this condition allows for subsequent monitoring of the sensor voltage for any increase following the vacuum application. If the voltage rises more than 0.2 volts, this confirms that the vent shut valve is functioning correctly. However, if the voltage does not change sufficiently, the shut valve may require replacement to restore proper system operation. In this step, conduct a visual examination of the connection between the EVAP canister and the EVAP canister purge valve. Assess the EVAP canister purge line for signs of damage and check that the canister itself is intact and free from wear. This connection must be secure and undamaged to ensure efficient operation of the EVAP system. A compromised line or damaged canister not only affects vapor circulation, but also poses risks for leaks. If either part is found to be faulty, timely replacement is necessary to maintain the overall integrity of the system and adhere to emissions standards. The 8th troubleshooting step involves inspecting the fuel fill pipe and fuel tank vapor recirculation tube for any signs of damage or poor connection. This is an essential part of ensuring that the entire fueling system functions correctly and that vapor routing remains unimpeded. Both components must be in optimum condition to prevent vapor leaks, which are critical to the EVAP system's function. If any issues are identified during the visual check, such as cracks or corrosion. Replacing the damaged parts is crucial to avoid further complications. If no damage is found, this suggests that these components are functioning properly. This step focuses on the shutoff valve, an important component designed to prevent liquid fuel from entering the EVAP system. Begin by carefully removing any misfuel inhibit device present. With the device out of the way, visually inspect the flap of the shutoff valve to ensure that it is indeed in the closed position. The proper closure of this flap is essential for maintaining appropriate pressure levels within the EVAP system. If the flap fails to close securely, it may necessitate replacement with a new main flap unit to restore functionality and prevent fuel spills. In the final troubleshooting step, the focus is on the flap seal of the shutoff valve and the mating surfaces. A compromised seal could allow fuel vapors to escape, leading to issues that would trigger the DTC codes being investigated. Ensure that there are no gaps, tears, or damage evident on the seal, as this might prompt a replacement of the entire unit. Additionally, inspect the mating surfaces for any signs of wear or damage that could interfere with the valve's sealing capabilities. If the flap seal is found to be damaged, typically, the entire main flap unit will require replacement to ensure the system's effectiveness. Once all necessary repairs have been conducted, it is crucial to perform a final verification to confirm that the issues have been appropriately resolved. This involves rechecking the DTC codes using the HDS. If no codes reappear, successful repairs can be verified. In the event that codes remain, it indicates that further investigation may be necessary. Clearing the DTC codes at this stage is often advisable to reset the onboard diagnostic system. After this step, the vehicle should be taken for a test drive to ensure everything is functioning as expected under actual driving conditions. To avoid encountering DTC P0455 and P0456 issues in the future, preventive maintenance is key. Regularly inspecting the EVAP system and its components, such as hoses, valves, and the canister, can prevent leaks from developing. Ensuring that all connections are tight and free from damage will extend the lifespan of EVAP components. Another critical aspect is adopting proper fueling techniques. Avoid overfilling the fuel tank and monitor for any spills during refueling. This proactive approach will help keep the EVAP system healthy and secure, thereby enhancing the vehicle's operational reliability. In summary, understanding the implications of DTC P0455 and P0456 related to the EVAP system is critical for maintaining Honda Accords manufactured between 2017 to 2023. With a comprehensive troubleshooting procedure in place, one can efficiently diagnose and resolve the issues linked to evaporative leaks. This guide emphasizes the importance of a meticulous inspection of all relevant components and underscores the vital role generated by preventive maintenance practices. By following these protocols diligently, drivers can ensure their vehicles meet emission standards while optimizing performance and longevity. Please like and subscribe to the channel. See you next time.